Okay, so I know that it seems like there's a lot of review for you guys, but basically we're trying to get ready for the team case analysis, which will count as 10% of our grade. So we'll have to do some review before we add to it. But majority of this chapter should be, well, most of your finance major. So majority of the material in this chapter should be review, okay? But still, the total risk, that variance calculation of a portfolio can still be tricky. Okay, so what are we going to cover in chapter 11? We're going to look at portfolio now. Okay, in chapter 10, we looked at how to calculate your average return, your expected return, and your variance and standard deviation calculation when you have only one asset. Okay, but in the real world, we rarely ever put all of our money in just one investment. Okay, we know that we need to diversify in order to minimize our risk. So we're almost always holding a portfolio with multiple assets. So what is a portfolio again? It is just a collection of assets, plural. So technically, if you're holding two assets or more at the same time, by definition, you are holding a portfolio. In that case, how do you calculate your return of the portfolio and how to calculate the total risk of your portfolio? Then we'll also look at how to decompose the total risk or variance or standard deviation of the portfolio. We'll see that your portfolio's total risk is not the simple weighted average of individual risk. So intuitively, we may think that, okay, if I invest 50% of my money in asset A and 50% of my money in asset B, then my portfolio's total risk should be just the weighted average, right? 50% of the portfolio's risk will come from A, while the other 50% of the portfolio risk will come from B, intuitively speaking. But that is not true. Because when we have a portfolio with multiple assets, we also need to look at interactive risk, which is how the return of asset A interact with the returns of asset B. Okay, and that's a very important concept. And we know that in the portfolio, for the most part, the unsystematic risk will be eliminated. So for the most part, when you have a very well diversified portfolio, what matters is what is remaining, which is the systematic risk. So how do we measure it? And once the number has been calculated, how do we interpret the number? Okay, so those are the things we'll talk about. Then we'll also talk about CAPM, which is world famous capital asset pricing model. And it is important to know that while it is a very important, very simple model, but it is also very inefficient. Okay, but your employer very likely will expect you to know it, so you need to know it really well. Okay, the application is very simple, and that simple application is one of the main reasons why it is so popular. Okay, not because it is that effective, but because it is very simple and it makes very intuitive sense. Okay, so let's start with the portfolio return. Okay, so when you have a portfolio, let's say with two assets, how do you calculate the return of your portfolio? And it's actually pretty simple because it's just a weighted average. Okay, weighted average of what? Of the returns of those individual assets. So here's the equation. Okay, so expected return is, this is the notation that we saw, right? So it's always capitalized E with either a big R or a little r. But in chapter 10, we looked at the expected return of one asset, right? And now we have multiple assets. In this equation, we have a stock and a bond. So S is the initial of the stock and B is the initial of the bond, okay? But usually we might just call them assets A, B, and C, etc. So it's the weight of portfolio weight of the first asset multiplied by the expected return of the first asset plus portfolio weight of the second asset multiplied by the expected return of the second asset. And now how do you get the expected return of those assets? They are from chapter 10. So if I bring back my chapter 10 PowerPoint file. So we talked about how to calculate expected return for each asset one at a time. That was on slide number 12, okay? So if this is the information, you will use the probability of the first asset, probability of the first outcome multiplied by the return of the first outcome, plus probability of the second outcome multiplied by the return of the second outcome, plus probability of the third outcome multiplied by the return of the third outcome, right? So we know that the sum of the probabilities should be equal to 100%. So if we have 85% here, then that means the probability for the last outcome should be 15%. Okay. So let's now go back to chapter 11. Okay. So the expected return for individual assets, those are given to us, or we reviewed how to calculate those in chapter 10. So once we have the expected return for each asset, we can just include the weights. Okay. So how do you calculate the weights? If you invest $10,000 in the stock and $7,000 in the bond, your portfolio weights are calculated. So here's the equation. Portfolio weight for, let's say, an asset, let's call it asset A, okay, will be calculated by using a fraction. In the numerator, we'll have dollar amount that's invested in A. Invested in A. And your denominator, it will be the dollar amount of your total investment. Okay, I know this part is very simple yet at this moment, okay, but later on when we calculate the portfolio variance, it will get nasty, okay. So for example, if you invest, let's calculate portfolio weight for, let's say the bond first, okay. So you invest $10,000 in stock and $7,000 in bond. So the amount that's invested in bond is $7,000. We're going to divide it by what? The dollar amount of the total investment. You invest $10,000 in stock, $7,000 in bonds. That means the total investment is the sum of these two numbers. So 17,000 is the denominator. Okay, so if we use 7 divided by 17, so our portfolio weight for the bond is 41.18%. Okay. So that tells us that 41.18% of our money is invested in bond. And since there are only two assets in here, then that means the remaining 58.82% of our money is invested in the stock. So if you're not so sure if that is true, we can apply the same equation. Okay, so let's calculate portfolio weight for, portfolio weight for the stock. Okay, so same equation. Okay, the amount invested in stock is how much? 10,000. That's my numerator. Divided by total amount of my investment. So it will be 17,000 in the denominator. If you plug in those numbers into your calculator, you should end up with 58.82%. Okay, so it just happened, and this is not a coincidence. Okay, when you add the two portfolio weights together, you should end up with 100%. So now we already have the portfolio weights. We can calculate, or just plug in the weights to calculate our expected return of the portfolio. So our expected return of the portfolio, sorry, I'm writing sideways because my keyboard is preventing me to move horizontally. So portfolio weight for the bond is here 41.18%, so 0.4118 multiplied by, well, the expected return for your bond and stock, they have been calculated for us. If not, you can go back to chapter 10 to calculate them on your own, okay? So expected return for the bond is 10.45%, so multiply by 0.1045. The plus portfolio weight for the stock is the 58.82%. So 0.5882 multiplied by here, the 7.5%. Oops, I plugged in the wrong number, sorry. The expected return for the stock is 10.45%. So the expected return for the bond, the expected return for the bond is 7.5%, so 0.075 here. And 0.1045 here. Okay, so when you plug in the numbers, you should end up with 9.24% as the expected return of your portfolio. Okay, 9.24%. So that's pretty simple. Okay, let's now look at the variance of your portfolio. And again, we'll have two methods. One is if you have projected information, just like what we saw, just like this, okay, projected information. And the next one is we'll look at what if you have historical information, okay, then your calculation will be different. And we're going to use that to decompose our portfolio variance into individual risk and interactive risk. Okay, so let's start with the projected information, okay, which looks like this. We have three potential outcomes, whether we may have recession or normal economy or economic boom. And each outcome has a probability, okay, and when you add those probabilities together, you have 100%. Okay, and we still have only two assets in the portfolio. To keep it simple, we have one stock and one bond. And those are the expected or projected return in each outcome. Okay. So when we have to calculate variance of the portfolio, when you have projected information, also known as ex ante information, you have to follow the 3 steps. And the key is that it is a very common mistake that people invert steps 1 and 2. Okay, but you need to make sure that these 2 steps cannot be inverted. You must follow the exact same process. Otherwise, you're going to have problem. Why? Okay, so we know that fundamentally we're solving for the portfolio variance, right? And while we use variance to measure risk or uncertainty, and where does the uncertainty come from? Does the uncertainty come from the different portfolio weights? No. The uncertainty comes from we don't know which outcome, which one of these 3 outcomes will become reality next year, right? That's where the uncertainty comes from. And therefore, in step 3, okay, we're using the backward induction. We are starting with our end results before we trace back to get the inputs that we need. Okay, so we start with the step 3. So the uncertainty comes from we don't know which outcome, which one of the 3 outcomes will be true. So that means here, okay, the expected return that we want is the expected return of each outcome, because that's where the uncertainty comes from, right? The second term here is always just the expected return of your portfolio, okay? So since here we want the expected return of each outcome, that's basically what we need to solve for in step 1, okay? So step 1 is to solve for expected return in each outcome, not expected return for each asset, okay? So that's important. And how do you solve for expected return for each outcome? We have to apply the portfolio weights, okay, for assets A, B, and C to find the expected return. Then in step 2, we will apply the probabilities to solve for the expected return of the portfolio. Now, step 3, okay, just so we're clear. So what we solve for in step 1 is this first term, okay, that's what we find in step 1. Then what do we find in step 2? That expected return of the portfolio that we find in step 2, that is the second component in the parentheses. Okay, and the probabilities is just the probabilities that we obtain from the table. So let's use the actual numerical example, and we will solve for, first of all, the variance of the portfolio, the expected return of the portfolio before we find the variance of the portfolio. Then we can convert the variance of the portfolio into standard deviation. So step 1, we're going to apply the portfolio weights to find the expected return for each outcome. So if I bring this table here, so how do we find expected return for each outcome? Well, we have 3 potential outcomes, right? We have recession, normal economy versus economic boom. So step 1, find expected return for each outcome, and first one is recession. Second one is normal economy. And third one is boom. Okay. So to find expected return for each outcome, we will look at only one row at a time, right? Assuming that we know with 100% certainty that we are going to have recession next year. So we're only going to look at the information here. If we know with 100% certainty that we'll end up with recession next year, the probability doesn't matter, okay? What we need is to apply the portfolio weights, okay? So portfolio weight for the first asset, let's say stock, multiplied by the return of that stock, plus portfolio weight of your second asset, which is bond, multiplied by the return of the bond, okay? So that's how you calculate the expected return for each outcome. Okay, So portfolio weights, okay, we don't have the portfolio weights, but we have to calculate that here. So if you invest 60% in the stock and 40% in the bond, what are your portfolio weights? So the equations are given to us on 2 slides earlier, right? Portfolio weight, it tells us the proportion of the money that's invested in each asset. So we start with the dollar amount invested in that asset divided by the dollar amount of the total investment. So based on that, our portfolio weight for stock is the amount invested in stock, $60, divided by $100 of total investment. Oops. Okay, there you go. So it would be 60%. Okay, so portfolio weight for the bond equals to the $40 that's invested in bond divided by the $100 of your total investment. So that's 40% here. Okay. Now, when you add the portfolio weights together, you should have a sum of 100%. Okay, that's one way to figure out whether you have miscalculated somewhere. Okay. Okay, so let's now calculate expected return for each outcome. For recession, I know 60% of my money invested in stock will earn a loss of 11% return. So 0.6 times negative 0.11. Plus the remaining 40% invested in bonds will earn me 16% return. So 0.4 times 0.16. Now we'll do the same thing for the next outcome, which is normal economy. So now we will only look at the information in the normal economy in the middle row. Okay. So assuming that if we know 100% certainty that we'll end up with the normal economy, again, that probability doesn't matter anymore, right? If we assume that there's 100% certainty that we'll end up with normal economy, then the 60% of my money invested in stock will earn me 13% return. So 0.6 times 0.13 plus the remaining 40% of my money invested in bond will earn me 6% return. So times 0.06. Okay. Now for the last outcome, we're only going to use these two R's here. Okay. So again, the equation is here, right? So 0.6 times 0.27 plus 0.4 times negative 0.04. So once we plug in those numbers into our calculator, we should end up with expected return for the first outcome recession is negative 0.0020, or you can say that it is 0.20% negative. Okay, the expected return for normal economy should be 10.2%. And the expected return for economic boom is 14.6%. Okay, so those are the expected return for each outcome from step 1. Okay, so you need to copy this down because I have to erase this in order to continue with step number 2. Let me make sure that you're still here. Yes, there we go. All right, so I'm going to erase just this part here. Okay, step 2 is to find the expected return of your portfolio. Okay, so step 1, we apply the portfolio weights. Now step 2, we're going to apply the probabilities now. Okay, so step 2, expected return of the portfolio equals 2. We're going to apply the probabilities. P1 multiplied by the expected return of the first outcome plus P2, probability of the second outcome, multiplied by the expected return of the second outcome. And we have 3 outcomes, so we need to do it one more. So plus P3, probability of the third outcome, multiplied by the expected return of the third outcome. Okay, so where do we get the P's, the probabilities? Here. Okay, where do we get the expected returns? From step 1. Okay, those 3 numbers, which I still have on the right-hand side of my screen. Okay, this is my expected return for the first outcome, expected return for the second outcome versus the expected return for the third outcome. So plugging in the numbers, P1 is here, 30%. So 0.3 multiplied by the expected return of the first outcome here. Okay, that's negative 0.0020. Okay, plus P2 is this one, probability of the second outcome, which is 40%. So 0.4 multiplied by the expected return of the second outcome, 10.2%. So that's the same as 0.102. Okay, we'll continue with the third outcome. P3 is the 0.3 here, or 30%. Then we multiply it by the expected return of the third outcome, which is 14.6%. So multiply by 0.146. So when you plug in the numbers into your calculator, your expected return of the portfolio should be equal to 8.4%. Okay, so step 2 is pretty quick. So I'm going to copy this number here because I need to keep it, okay? I need to use it in step 3. So that is 8.4%. All right, so this is from step 2, okay? Now, step 3, we are ready to calculate our variance of the portfolio. So I'm going to erase this. The eraser is a little small. Okay, so step 3, to calculate variance of the portfolio, it will be, okay, we'll have to apply the probabilities because again, we use variance to measure uncertainty or total risk. While the uncertainty comes from, we don't know which one of these outcomes will become reality next year, okay? So we'll have to solve for average of the deviation, we'll apply the probabilities. So probability of the first outcome multiplied by the squared deviation from the mean. The mean is the average. So the second term is this expected return of the portfolio that we calculated in step 2, so 0.084. And this first term in here, this will be the expected return of the first outcome that we obtained from step 1. So it is this number here. Okay, so negative 0.0020. Oh, well, anyway, the equation is here, okay, on slide number 4. So I don't need to copy that here. Now, when our P1 is what, 30%. It is this P1 here, okay? So 0.3. Then we plus P2, which is 40%, so 0.4 multiplied by, again, the square deviation from the mean, and the mean is this 8.4% from step 2, 0.084. And here we need to plug in expected return for the second outcome, which is the 10.2% from step 1. So 0.102. Then we plus P3. P3 is, well, where's my cursor here? 30% multiplied by expected return of the third outcome, which is the 0.146 minus the average 0.084 squared. Okay, so again, when we calculate for the variance, miscalculation or rounding error can occur very, very easily. So to make sure that we do not have rounding error added to another, we typically will reset the calculator to 6 decimal spaces. So to reset, we press second, format, 6, okay, because we want 6 decimal spaces. Enter. Then to get out of the setting, we'll press second and quit, okay? So to calculate this, step 1 is to take care of what is inside of the parentheses. Step 2 is to square that deviation. Step 3 is to multiply it with the probability, okay? So let's do this together. So in the first parentheses, this is a negative number, okay? And with this calculator, you have to enter the number before you change it into a negative. So 0.002 negative. Then we minus the 0.084, okay, close parentheses. So this is just step 1. Now step 2, we're going to square that deviation from the average. So square. Step 3, we multiply it by 0.3. So that's 0.002219. That's just from the first outcome. And we're going to add the same thing to the second outcome. So we'll use plus, and we're going to use open parentheses twice. If you're not so sure if 2 is enough, you can use more than 2. Okay, but start with inside the parentheses. I have 0.102 minus 0.084. Close parentheses for the first time. We're now square that deviation before we multiply it by the probability of 0.4. So 0.4, close parentheses for the second time. So 0.00013 is from the second term. Okay, when you press equal, this is the sum of everything that we have calculated so far, okay, in this circle. So let's plus open parentheses twice again, and we'll take care of the very last term here. Again, we'll start with inside the parentheses. So 0.146 minus 0.084. Close parentheses for the first time. Step 2, we'll square that deviation. Step 3, we multiply it by the probability of 0.3. Then close parentheses. Okay, so the third term here is 0.001153. When we press the equal, we have the final number. So the variance of the portfolio is 0.0035. That's the variance, right? So if you are asked to find the standard deviation, what do we do? The standard deviation will be the square root of this number. So standard deviation is just the square root of the variance, right? So we will take the square root of this number. Even though I only copied down 4 decimal spaces, but we know that to convert the variance into standard deviation, we still use whatever outcome that we have here to avoid rounding error. So just take the square root. So your standard deviation is 5.92%. Okay, you can say it's 0.0592, or you can say it's 5.92%. All right, so that's the variance of the portfolio. That's if you have projected information, also known as ex-ante information, okay? But what if you have exposed information or actual historical information? Then what do we do? Okay, so right now we're going to decompose the portfolio's risk or variance into 2 other risks, okay? So again, intuitively, for those of you who are pretty math oriented, you may think that, well, if 50% of my money is invested in asset A, well, another 50% of my money is invested in asset B, then variance of the portfolio should be the simple weighted average, right? So 50% of the risk, portfolio risk, will come from A, while 50% of the portfolio risk will come from B. But in fact, that is not true, okay? Because we also need to look at how would the returns of asset A interact with the returns of asset B. And that interaction between across the returns of multiple assets, that is called interactive risk, okay? So with historical or exposed information, we can decompose the portfolio risk into individual risk. And that individual risk specifically is the individual total risk from each asset, right? Like the variance of asset A and variance of asset B. Okay, total risk, just so we're clear, measured by either variance or standard deviation. Okay, well, standard deviation is preferred. So I'm just going to use initials. Okay, standard deviation. An interactive risk across 2 assets at a time. That interactive risk is measured by what? By, you can use either covariance or correlation, while correlation is preferred. By correlation, or I'll go ahead and give you the other one, or covariance. Covariance. So between the correlation and covariance, correlation is preferred. Okay, so remember from Finance 330, and just so we're clear, the correlation is typically notated by this P-looking thing that's pronounced rho. It's a Greek symbol here. Let's say if we're trying to look at correlation between two assets, between assets A and B, okay, and correlation can only be viewed between two assets at a time. So if you have three assets in the portfolio, then it gets complicated, okay, because you can only look at correlation or interactive risk between two assets at a time. Well, correlation is bounded by two particular number, and that's why we prefer correlation over correlation. Correlation over covariance, okay? So correlation is bounded by -1 and +1. Okay, it's hard to see. Let me try red color. Bounded by -1 and +1. Okay, and I hope this rings a bell, or at least it sounds somewhat familiar. So if two assets have a positive correlation, okay, so with the extreme that it can never be greater than a +1, and it can never be lower than a -1. Okay, that's what I mean when I say that it's bounded by -1 and +1. So it has to be in between these two numbers. Okay, so let me insert a slide. For this review, okay, so a positive correlation means that the returns of the two assets tend to move in the same direction. So that means if the return of asset A goes up, then the return of asset B also tends to go up, right? Because they tend to move in the same direction. So that also implies if the return of asset B goes down today, then the return of asset B also tends to go down, because the returns of the two assets tend to move in the same direction when the correlation is positive, okay? And that implies if these two assets have a negative correlation, it means what? It means that the returns of the two assets tend to move in the opposite directions, okay? Means the returns of the two assets tend to move in the opposite directions. That means when the return of asset A goes up today, the return of asset B tends to go down, okay, because they tend to move in the opposite directions at the same time. And that also implies if the return of asset A goes down today, then the return of asset B tends to go up, okay? They tend to move in the opposite directions. So again, we use correlation or covariance to measure interactive risk. It tells us how do the returns of the two assets interact with one another. Okay, oops, so going back to here. So let's start with the simple scenario. When you have only two assets, let's call them assets X and Y, or you can call them assets A and B. Either way is fine. Okay, in here we're using notations, asset X and asset Y. Then we see that here, using the earlier numerical example that I say, if you invest 50% in A or 50% of the money in asset X and 50% of the money in asset Y, we may think intuitively that 50% of the portfolio's total risk will come from X and the other 50% of the portfolio's risk will come from Y. But that is not true, because based on this equation, that we need to square the portfolio weight. So if portfolio weight for asset A is 50%, see? When you square that, 50% square, it will actually give you 0.5 square, it will give you 25%. So that means that if you invest 50% of the money in asset X, only 25% of the portfolio risk will come from asset X. Well, if you invest 25%, the remaining 50% of the money in asset Y, the only 25%, right? You have to square that portfolio weight. So only 25% of the portfolio risk will come from asset Y. So when you add these two terms together, we only have 50%, right? So in this case, then where would the other 50% of the portfolio risk come from? It will come from the interactive risk. So we'll have to also look at how would the return of asset A interact with the return of asset B, okay? So it's the portfolio weight of the first asset squared multiplied by the variance of the first asset, right? This is the sigma square. So that's variance of that first asset. So this is the total risk from asset X. Then here, the second term is the total risk from asset Y, okay? Then here, this third term, we have 2 multiplied by the portfolio weight of the first asset, multiplied by the portfolio weight of the second asset, multiplied by standard deviation of the first asset, multiplied by standard deviation of the second asset, and multiplied by the P-looking thing. That's the correlation that we talked about earlier, okay, correlation. But when you multiply these 3 terms together, these 3 terms multiplied together, that is the covariance. Okay, covariance. Okay, so if we know, by the way, if covariance between asset X and Y is calculated as standard deviation of X multiplied by the standard deviation of Y multiplied by correlation between these 2 assets, now there will be some situations that you may have to rearrange this equation to solve for the correlation. If you have to solve for the correlation, which is the P-looking thing, I hope we can all see that all we need to do is to divide both sides by this term. Okay, so correlation, okay, between the assets X and Y equals 2, we start with the covariance, okay, between these 2 assets, then we're divided by standard deviation of the first asset multiplied by the standard deviation of the second asset. Okay, that should be a pretty simple maneuver to convert covariance into correlation. Okay. And by the way, just so we're clear, this third term here together is the interactive risk. Okay, specifically the interactive risk is measured by this term. Okay, you can use either correlation, which is just this term here, or you can use the whole covariance to measure interactive risk. But correlation is a more precise measure because we know that it's bounded by these 2 numbers. It can never be lower than a -1, and it can never be higher than a +1. Therefore, it's easier to interpret, right? We can look at the number and see how close it is to the boundary, right? If it is positive 0.99, then we know that it's almost perfectly positively correlated, okay? It's because it's so close to the upper bound, okay? Well, covariance, it can only tell us whether it's positive or negative, but there's no upper bound and no lower bound. So without a boundary, it's harder for us to interpret the number. So typically, once we have calculated for the covariance, we will convert it into correlation this way in order to figure out how positive or how negatively correlated that the returns of the 2 assets are. Okay, so that's if you only have 2 assets in the portfolio. Okay, but what if you have 3 assets in the portfolio? We'll see that the interactive risk becomes more and more important. So with 3 assets in the portfolio, if we have assets X, Y, and Z in the portfolio, then we're going to find that we still have 1 total risk term, also known as variance term, for each asset. Where's my cursor? I'm trying to bring my cursor back. Here we go. We're going to have 1 of the total risk or variance term for each asset, 1 for X, 1 for Y, and 1 for Z. So there we go. So we'll start with portfolio weight for asset X squared multiplied by the variance of X. Right, we'll do the same thing for the next asset, which is asset Y. Portfolio weight for asset Y squared multiplied by the variance of asset Y. Plus, we have 1 more asset, portfolio weight for asset Z squared multiplied by the variance of asset Z. Right, 1 for each asset. So that individual risk terms are pretty simple. But now let's look at the interactive risk terms. Okay, that's where it gets complicated because you can only look at correlation between 2 assets at a time. When there are only 2 assets, X and Y, there's only 1 correlation, right? But what if there are there's one additional asset in the portfolio. We now have XYZ. Well, you can only look at the interaction between two assets at a time. Then how many interaction terms do we need to look at? We need to look at how the returns of X interact with the return of Y. That's the first correlation. We also need to look at how will the return of X interact with the return of Z. So that's the second interaction. And there's also another interactive risk term or interaction term between assets Y and Z. So when we add only one additional asset to the portfolio, right, from 2 assets to 3 assets, we have, rather than just one interactive risk term, we now have 3 interactive risk terms or 3 interactive risk terms, okay? So which one you want to incorporate first, it doesn't matter. So let's say we're going to incorporate the interactive risk between X and Y first. Then we're going to plus 2 times W, X times WY, times sigma X, sigma Y, times rho between X and Y. That's the interactive risk between assets X and Y. Okay, you can see I hope you can see a pattern, XY, XY, XY here. Okay, so now if we want to look at a second interactive risk term between assets X and Z, then it will be pretty similar. 2 times W, in this case, X times W, Z, times sigma X, sigma Z, times rho, this should be Z, times rho XZ. Okay, so you can see a pattern here, XZ, XZ, XZ. Okay, now we'll have one last interactive risk term between assets Y and Z. So we'll have to plus 2 times WY times WZ times sigma Y times sigma Z times rho YZ. Okay, so we have 3 interactive risk terms now. So just to demonstrate that as we increase the number of assets in the portfolio, we have more and more interactive risk terms. And that tells us that as the number of assets in the portfolio goes up, the importance, this is very important, the importance of your interactive risk is increasing very, very quickly. Okay, the interactive risk is more important than your individual assets total risk. Okay, so now what if you have 4 assets in the portfolio? Just to see you how fast that the number of interactive risk is going up. So if you have 4 assets, let's call it assets X, Y, Z. Well, let's add one more, W. Okay, so we'll have first interactive, first correlation, second correlation, third correlation, fourth and fifth and sixth. So we now have 6 interactive risk terms when you add just one additional assets. So how many interactive risk that we will have? This is calculated as n multiplied by n minus 1. Oops. Let me go here. N multiplied by n minus 1 divided by 2. So if you have 2 assets in the portfolio, how many interactive risks do we have? We'll have to plug in 2 times 1 divided by 2. We'll have only interactive risk term. But if we have 4 assets in the portfolio, n equals to 4, we'll have to plug in 4, right? N equals to 4, so 4 multiplied by 3 divided by 2. So that will give us 6. So if you have 4 assets in the portfolio, you have a total of 6 interactive risk terms. And that's what we saw here, right? WX, WY, WZ, right? Also here, 1, 2, 3, 4, 5, 6. Okay, we'll have a total of 6 interactive risk. So the important part of this slide is to know that as the number of the assets in the portfolio goes up, the importance of interactive risk increases very quickly, while the portfolio's variance is not the simple weighted average of individual risks. Okay, that's a very important 2 concepts that you need to know. And of course, you need to know how to calculate the variance of the portfolio with this equation. Okay, so that's the end of the lecture today.